Yo, happy Friday. So we're going to continue with the graph toolkit today. Yesterday we implemented the graphical side of things. The stream before that one, we implemented the run type side of the node system. But we left it pretty open-ended or easily adjustable, because today we're gonna try, I'm saying try because this might get messy, but we're gonna try to sync these two so that what we actually do here results in something during runtime, or something we can actually use in our game. Alright. What's up, Jankel? I've been watching you do this for 2 years now. You indeed are slowly developing. Thank you for watching for 2 years. And yeah, game dev is pretty slow most of the time, I would say. So yeah, like, this is how I want to define how at least my creatures looks. And maybe we can even define how the creatures probably not behave, maybe even behave in here, but at least how their stats. But okay, so to our help we have a sample here. Which has nodes defined like we do, have a graph defined as we do. I wonder if we need to do this. Maybe we do. Maybe not yet, but this could be nice to remember. That we can check if the graph is successful by doing this. Just a log warning though. Maybe that's enough. Okay. Okay. So we have set background node, runtime node, visual novel runtime node. So the equivalent for us is visual novel runtime node is our generation node. Set background runtime node is any of these nodes. Okay. I want to see this one. Okay. Okay. And that's pretty much exactly how our look right now. Okay. Set background node. So this one just keeps the information. Okay. So if we take a look at this node, public sprite, background sprite, and then we take a look at set background node here. Then we have input sprite. Okay, and then we have executor, which takes a set background runtime node and a visual novel director. Visual novel director? Hmm. Hmm. So we have visual novel runtime graph, which is just a list of nodes right now. I think we want to be a little bit more detailed, but we'll see. Task execute async t node. Hmm. Hmm. I wonder. I want to get the bridge between editor and runtime. So like, where do we fill this one? Maybe visual novel importer. Hmm. Okay. Yeah, I guess this class is the one where most of the stuff happens. BJK, that's a builder. Yeah, like this is the one, this is the bridge between the visual graph and the runtime graph, right? So this one converts this to something we can actually use during runtime. So we want to have something similar that takes these graph nodes we have defined and converts them to generation nodes and a hierarchy. I wonder if we want to keep it like this. I wonder if this is a good idea. So set material, for instance, it defines the outputs it has like this. Or actually, this is the input. It defines the output like this. I don't know. VJK, you should find the root of your graph. I'm not entirely sure what you mean by that. The start of the graph won't be as easily defined in our case. Like you should be able to start from various places in the graph. It's not that important. It's not sequential like a visual novel. The only important thing is that when we're trying to execute when we try and execute a new node that we have done the previous executed the previous nodes. Okay, what's up, Kevin? Have you changed your name on YouTube? I didn't recognize it. But that being said, I'm not entirely sure I like how our runtime nodes are implemented currently. So we have interfaces like this where we define outputs. Kevin, no, you change it to the user ID, whatever. I haven't done anything, I can promise you that. Maybe this is okay. So we can remove serialized here. Okay, maybe we can create something similar to the builder in the example. And we can work with the current setup of our runtime nodes. I don't think it's that bad. I'm not entirely sure of how we will solve it when we want to do multiple objects, though. I wonder if, like, one easy approach to fix it would be that for every output here we change it to a list. so that every runtime node returns a list of t then, I guess. I will get it. We will get to it eventually. So I think, yeah, we're gonna go with this. Let's see what we have. Yeah, so what we can check here, so instead of so in this example they start with where do we have it? They have something called start nodes. We have, like, a start node for us could be any node that doesn't have any inputs. So I guess this one is a better example because this one actually has inputs. So we can sort it by, first we do nodes that don't have any inputs. Then we start with nodes that has inputs, but they don't actually have any input, if you know what I mean. So empty inputs. And when we have done those two, we can probably just go yeah. Kevin, is your graph has one output node? Yeah, we have one output node, so we could go the opposite direction as well. That's true. We're always just gonna have one output node. At the ending of this graph, I'm trying to think how a graph, in what case you would have a graph with multiple output nodes. There probably exists a ton of examples, but we could go backwards here. So we start with the end node, then do this one. Yeah, so what is it? Depth first, search. Kevin, yep, start run from the leaf. Yeah, we'll probably try it. Yo, what's up, Antonino? Happy Friday, happy Friday. Breadth first. To be honest, to me, I don't think it matters. But what's the difference if we do this one, then this one, then this one, then this one, then this one? Or if we do... Yes, it does. Yeah, make your case. ON to O1 in finding. Okay. But like honestly, where I'm getting from is no matter what we do, we're just gonna iterate through each node once, right? So we can start with this one, we go to this one, then this one. Oh, we don't have any inputs here. We execute this one, then we're back at this one. We have other inputs, so we jump to this one, then this one. Oh, we don't have any children here, so we execute this one, then we have iterated through both of the children here, so we execute this one, and then we're back at this one. We haven't done this one, so we go to this one. That's how we want to do it, right? We don't want to find anything, or we don't want to search, really. We just want to execute. We just want to loop through each node once. Antonino, thank you so much for the donation. Quote, thanks for keeping me company in the mornings at work. Grab a coffee and pretend I'm having it with you. Appreciate it. Thank you for keeping me company. I appreciate it. And the donation. Kevin, yes, but if you do, you have to use many call stacks. Okay, now we're talking. Okay. Breadth first search already solves that problem. Yeah, like I'm not committing to any of the two. I'm just trying to gather information here. You seem to be pretty sure. So I'm leaning towards that being the answer. But like I want to convince myself of this, right? Before we commit to anything. So let's say that we have it organizes nodes sequentially in baking time. Okay, I get it. Yeah. Okay, maybe. We're starting to get at the point. So let's just draw a node tree. I don't know. If we were to do breadth or depth first, would we go how should we draw this? We have this one, and I hate that they use different visualization for these two. So depth first. 1, 2, 3, 4, 5, 6, 7. Yeah, exactly. So for depth first, we would do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Breadth first, we would do... Don't we have any... Yeah, here we would do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So like when I see this, why wouldn't I want to do depth first? We want to do depth. So if we use depth first, so we take this, so the end node, then we go to this one, then we go to this one. We don't have any input here. So then we do this one. Okay. And then we can do this one. So then all of this is done. We've built it up. Because if we do depth first, then we can build it, then we know which nodes we need to do. Or I guess we could do... Or do we want to order it? Kevin, on second thought, DF's also okay? Question mark, question mark. I'm thinking that both is probably okay. I don't think there's a bigger difference between them, but now I'm starting to lean more against breadth first when we build the runtime node. Because look at this. We can do... let's see, 10, 9, 8, 7, 6, 5. Yeah, I think we can do both. Yeah. It's like, I think I'm almost sure that in our case, there's no difference in the order we do. So let's say that we just pick one of these and then we order them biggest number first, and then we just iterate through that list. That's pretty much all we need to do. But we still doesn't handle the case where, like now I'm thinking, so when nodes can return multiple or a list of stuff, but that's probably okay. But you know what? Also, Kevin, BFs uses heap in baking time, so be aware of it, but I think the difference of them is minimal. Okay, yeah. Like, I'm wondering if the way we have built up our node, runtime nodes, maybe we can just order them however we want, and then we solve it recursively. Because let's take a look at this one. So set material graph node. So set material here, what we do is we have input game object and input material. When we try and fetch these, we just do input material, get material. So instantiate material. When we try and get material, we check, is it instantiated? If it's not, we instantiate it and then we return it. So fuck it, we might as well just, if set material is the end node, we just run this one. So if we just run this one, that means that we're going to jump to game object, try and get the input game object, which in this case is set mesh. So when we try and do this one, we're going to try and get the mesh from input here, which is dynamic mesh to mesh. So then we call get mesh from dynamic mesh, which is dynamic mesh generator. And that's the end node. So we generate this one and then we go through, up through the heap. Depends on how much memory we want to use, I guess. Okay, we're gonna do a rough builder in our case, and then we're gonna test it, see how it works, and we're gonna be open to changing it. So we know that not Directograph, but Visual Novel Direct Importer, right? Yeah, we know that like most of the optimization, or we can optimize by building it differently. But what I'm wondering now as well is, wouldn't we want to have in our graph nodes, wouldn't we want to have something like this? Let's see here. Public generate, or like, let's call it generation node 2. Generation node. Wouldn't this be nice? And then we check, let's see here. Fuck, I want to commit this first of all before we start. Before I start breaking it. Get input port. Gets the first port connected, is connected. All ports connected to this port. Okay, yeah, it can be an output port. Yeah, I think we want to go yeah, from the end. So I'm wondering if we just want to keep it like this. 2 generation node. And then we do dynamic mesh. But we probably want to rename this one. But let's say dynamic mesh generator. That's not the one I want. Kevin, you can see and use my building process in my GitHub link. Yeah, I looked through it briefly. Didn't have much more time, unfortunately, but we're gonna look into it soon, I think. But I have a plan of action currently. I want to see how it looks first. Like, I want to see if this is a valid way to do it. I don't want to be affected by outer influences just yet. We're gonna get to it soon. We can do some comparisons and stuff. But dynamic mesh to mesh graph node. Like, what I'm wondering is dynamic mesh to mesh. Here we have it. We're gonna rename this one as well. But so we have generation node to generation node, and we do dynamic mesh to mesh. Let's just call it node. New dynamic mesh to mesh. And maybe we can make them buildable. So we do, what do we have? We have setup. Oops, that's not the one. Here we go. We have input, and then we have, yeah, the mesh. So input dynamic mesh. I'm wondering if we're gonna build it the same way, because, yeah. So we do it like this, and then we take node.input is equal to, and then we use this one, get connected ports. Or we get the port with the dynamic mesh, and then we create that node. Maybe. I think I want to try it this way. But yeah. And then we need a scriptable object as well that saves the node we're generating. But we're just gonna okay, I think I have a plan of action now. Okay, so this is what we're gonna do. I'm gonna commit this stuff first of all, because I'm afraid I'm gonna screw some stuff or fuck it up. Finalizers, we're gonna rename this one to monster or to creature, because what we're gonna do here is we're gonna get a game object input, and we're gonna add a creature component to it, and then we return it. I think. And then we're also going to rename all of these. We're going to add a postfix. We're going to call them set mesh generation node, or do we want to maybe runtime node is better. Yeah, okay. Let's do it like this. Yeah. we're gonna rename all of these to X editor node. We're gonna rename all of these to X runtime node. I think we're gonna remove this namespace as well. So we just have game creatures generation nodes generation. Yeah, editor creature generation dot node dot editor. Generation dot editor generation dot runtime. Okay, let me commit this. I think dynamic mesh node system. Yeah, I think I'm just gonna commit this whole creature folder. Yeah. Then we're just gonna call this one create first iteration of editor graph. What do we want to call it? Creature dot generation creatures generation Oh, wait. Yeah, we do editor creatures generation. Yeah, of course. Okay. Let's see here. Add first version of related to 201 and 209. And then what we're gonna do is examples to do. Wow, do we get mermaid re-rendering every time we do this? Okay. So what I want to do now is I want to put these, so the editor nodes, I want to put them under editor creature generation graph. Add or change the namespace of all editor node classes to editor dot creature. Fuck, shouldn't it be creatures? Yeah, but maybe we want to keep that in singular as well. But yeah, we already have it for the other file, so we might change it eventually. But editor.creatures.generation.graph. That is going to be the namespace for these. And we want to do something similar here. Oops. Yo, what's up, Spires? Happy Friday, and thank you for the raid. Appreciate it, appreciate it. To game creatures generation graph. There we go. I think that's what we're gonna do real quick. Just to make it look a little bit nicer. Let's create the rest of the to-dos as well. So what I want to do after that is I want to change the name of these and these. So change the name of all nodes to be of the form X editor node. Oh, fuck, do we want them to be... Maybe we just want them to be the same name. Nah, that fucks it up when I want to do a quick search. So yeah, X editor node. And now we're gonna do something similar here, where we do change the name of all game nodes to be able to form X runtime node. Think that's probably gonna be the easiest for me to understand. Okay, so let's get these two. Let's continue with the to-do. So what I want to do then is we are gonna change, we're gonna make finalize. This one is gonna be, we're gonna change it to a converter. So it's going to be game object to creature. Yeah. And we're going to remove finalizers. Change to yeah, but we're going to change this one to runtime node. Change finalize runtime node to game object to creature runtime node. but we're gonna... And we don't have this one node implemented here in the graphs yet. No, we don't. No, we don't. So implement game object to creature editor node. Okay. And then what I want to do is I want to create what do we call editor. Where do we have creature generation graph? I think I want to rename this one creature generation editor graph. And then I want to have a creature generation runtime graph, which is a scriptable object. And that's how we save it. And then I guess we want to have a creature generation graph runner or executioner as well, which executes it. But fuck, storing it like a... Yeah, if we store it as a scriptable object, we definitely don't want to have... We don't want to make it work like with caches like this. This one right here. Yeah, because the creature generation runtime graph, that scriptable object, we don't want to alter it. So as soon as we change the editor graph, we want to generate a new runtime graph. But during runtime, that graph is going to stay the same. We're just going to utilize it to generate stuff. So then it's not as straightforward as I initially said. So then we probably want to order them in some specific way. And we don't want to do it recursive, that is. So if we just order them by biggest index first, execute this one, execute. Or I guess we could... add some sort of ID key. So we cache it, but with ID. So for the next creature we generate, we check if, when we're trying to generate this one now, is it the same ID? If so, return the cached value if it's the same, otherwise don't. But that's not the best way, or that's not really a clean way to do it. Should we do instead? Okay, so fuck this. We never want to do this. But on the other hand, like, yeah, if we have, yeah, we will probably have a mesh. Yeah, we will have a node that generates something and we want to use it in multiple different nodes. So we need some sort of memory like this, or cache, but not exactly like this. We are gonna have, yeah, we're probably gonna have to do it in the generation graph run, or generation runtime graph executor. That's where we're gonna have to keep the memory or something. Fuck. And we haven't even started, or we haven't even introduced the randomization and stuff like that, which we are eventually gonna get. We're gonna have to work around and with. But I think we can continue, and then when we get to the problem, I can better visualize it or explain it. Or maybe we can clear it in between, but I don't want to... I don't want to alter scriptable object during runtime. Yeah. Yeah, and we're gonna try and do... So when we do... when we run the graph during runtime, we want to make it so that we can... Like, we want to be able to run this graph on a secondary thread, so we don't want to alter anything in the scriptable object. Because if we do... we might get some very bad errors. So what I want to avoid as well, I don't want to introduce a third representation of this graph. Because what I'm getting at is if we have something like this, dynamic mesh to mesh. Yeah, let's duplicate this one, put it here, just to show. So in this case, we have one node that outputs whatever it generates to two nodes. And we're going to have a lot of these. When this node asks for it from this node, we don't want to regenerate it if this one has already asked for it. And the idea is that we build this one to a scriptable object. That's the runtime graph. That's the rules and flow of the graph. But then when we run through the graph and we start generating values, we want to use those in a specific way as well. Fucking hell. And that's why they have set background executor. Fuck. Makes sense, but I guess. So are we gonna have an executor for every... Really, really, really? Kevin, I did multi-thread in my graph. It uses multiple locks and was hard to debug. Oh yeah, I can imagine. And we're probably gonna look through your example soon. I'm trying to get a broad picture of it. I don't know if we're gonna do this. Like, the main idea for us is that, like, this graph, runtime graph, is gonna be used to generate creatures. We definitely don't want to take time from the main thread when we generate the creatures. So it's not like we want to multi-thread the graph in such a way that all nodes are being executed independently. It's just that we want the whole graph to be executed on a separate thread. But, so if we generate two different creatures that uses the same graph, then we're gonna have, like, those two might not work on the same thread. But they're gonna use the same runtime graph descriptor at least, or the same, yeah, this one, I guess. Where do we have it? This one, I mean. But okay, it looks like we want to have executor 2. Okay. Not sure I want to solve it exactly like this, however. So... I wonder if I want to... Maybe we just want to do it as wrapper classes, or is that weird? Or we could... we could actually just have it in a dictionary, couldn't we? Yeah, probably. So... instead of having it like this within here, we just do... we set this one as the key in the dictionary and the output as the value. And then just run it through like that, maybe. That would at least avoid having to define this stuff. And maybe we can start with that, actually. Okay. So back to the to-do list. Now I have a pretty rough sketch of how I want everything to work from start to finish. So we want to implement a creature generation graph. We want to change the name of this one. Have I already... Yes, and then we want to implement implement first iteration of creature generation runtime graph, which should be scriptable object. And then we want to have implement first iteration of creature generation runtime graph executor. Okay, that's great. And here we want to implement, what did they call it? Visual Novel Directory Importer. We are gonna call it do I just want to call it creature generation editor graph exporter? Importer, scripted okay, it's actually importer. Maybe. Yeah, let's do implement first iteration of creature generation graph. We're gonna leave editor or runtime. Importer. Feels weird to say importer though, but okay. It's a little bit of a mess, but I think so. Everything that exists in editor, so editor graph and editor nodes, they have a equivalent in runtime. So we have a runtime graph and a runtime nodes. Then we have creature generation graph importer, which converts a creature generation editor graph to a creature generation runtime graph. This is a scriptable object, which it pretty much just describes the graph. But then we have a creature generation runtime graph executor, which takes this information and executes it and leaves us with a creature, which we can then spawn in the world. I think it's okay. I think a lot... where do we have it? This one, a lot is going to depend on how we implement this one and this one. I think those two are going to be the two most important parts of this system. Not too sure, but that's what I think right now at least. Okay, let's start with changing the namespace of these and these. So let's start with the runtime and change the namespace. Yeah, here we have node rules. Namespace game creatures generation graph. Okay, so that's the namespace at least. Change the name of all game creature generation graph nodes to be of the form X runtime node. Okay. So this one, we're gonna change this one to okay. Generation node, yeah, we want to rename this one. Generation runtime node. Set mesh runtime node. Okay, beautiful. And then change finalize runtime node to game. Okay. So we're gonna rename this one to in fact, I want to rename all files as well, I think. But this one is going to be game object to creature runtime node. Generation runtime node set mesh runtime. Okay. I think we have it. Did I game object to creature? Yeah, we didn't rename this one here, so game object to creature runtime node. So let's move to these then. Change the namespace of all editor node classes to editor creatures generation graph. So the exact same, but we start with an editor. Creature generation strings. Although, yeah, we're gonna get to that one eventually. Okay. Then we want to change the nodes as well. So set mesh editor node. Okay. And then I want to rename them here as well. One sec. Okay, back. Sorry about that. Dynamic mesh generator. Fuck, have I fucked up? Generator. Dynamic mesh generator node. Editor node. Hmm. Change the name of creature generation graph to creature generation editor graph. I think that's the last thing. Creature generation editor graph. Okay, before we commit this, we're just going to compile it and see if we have any errors. I'm a little bit afraid that our graph so far will be wiped, but that's okay. That's okay. Okay. Do we have a short command though for just, or short command I mean, for just recompiling? Because something is wrong with the IDE here. The type of namespace name nodes does not exist. Game creatures generation dot nodes. Yeah, but we don't. It's a graph, right? What do we have? Okay, because if we do this then, float A, recompile, now it's gone, remove, okay. I might have fucked up with this last one as well, but we're gonna get to it. Graph is a namespace, but it's used like a type. So this one, yes. Guess we could just do... Can we do this? Okay, beautiful. And yeah, then we have some errors here, of course. So we're just gonna do joink. and add node. And then we're back to this point. Okay, so everything works now, but we have some different names. Okay, great. Fuck, I would love to have a separate name here. Dynamic Mesh Generator Editor node. There has to exist a way to change this name, right? Let's Google it real quick. Or let's commit this first. And let's add display names to editor node. Okay, great. I want to double check this one if we can get a answer to this one quickly, and then we can just do it just so it looks a little bit nicer. Make it a little bit more understandable. Unity Graph Toolkit display name for nodes. Basic node. Maybe you aren't able to currently. Header, I think you should be able to change the icon as well. But I'm a little bit worried if we check the API. We take a look at node. Properties. nothing with name here. We have node options, but that's like the content of the node. Here we have a lot of get and on define, and then we have implements inode. Okay. So let's jump to inode then. Maybe we have something here, but it's only a lot of gets and counts. This one doesn't implement anything, I don't think. Yeah. But this has to... There has to be eventually. So when this is no longer an experimental package, must be able to set a display name instead of this. I hope. But okay, let's skip that task for now. Yeah, let's wait with... let's do this one. We want to do it here as well. We're gonna do... what do we have? Game object to creature. Let's see here, input. And right now we just return input to game object. Okay, so what we're gonna do is... Okay, we actually don't want any cache yet, so we're gonna remove that as well. Remove hash implementation in runtime node. Because we're going to solve this in the graph executor instead. Because these nodes are actually going to be located in a scriptable object, and we don't want to alter any of those. So yeah, I want to fix this one first. And the output is not going to be a game object. It's going to be... Might want to fix this eventually. Output... Creature. For now, we might as well return input dot game object add component creature, but eventually we're gonna add a hell of a lot of stuff here. Probably stuff implemented or generated in the graph as well. So I'm talking about attributes and stuff like that. I really thought it did. Is this just a... No. Okay, quick fix. Let's see. No code options available. What if we do this and then this? Okay. Oh, game object to creature runtime node. Oh, could it be? Could it be? Yes, of course. We need to do... but not here. Like this, I think. Yeah. Hmm. And then we want to change this one to... Okay. Okay. Yeah, let's fix this one real quick again. Or not again, actually. The first time. And it's a converter. So I'm just going to duplicate this one. And we're going to call it game object to creature editor node. Antonino, hi again. Do you have any advice for not abandoning a project? I find myself constantly creating prototypes without ever finishing an actual game. Ooh, that's a hard question. Like in the past, I abandoned a couple of projects. Which unfortunately, yeah, like the only reason I haven't abandoned this, or not the only reason actually, is because I know how much hate is probably a strong word, but how much I actually hate myself for abandoning projects. But I've thought about this a lot because I've been eyeing, if I find the time, if I get the time, to also do some smaller game project on the side. And I think if I were to start a new small project and I didn't want to abandon the project, I would define the requirement list for that game. Like, what do I need to implement and what do I need to do for it to be the least viable game, or like, what do I need to do to implement this as 1.0? And then I keep that to-do list small. So like 1.0 is really, really rough, which means that it's not going to take that much time to make it. And then I just set my eyes on that, like finish 1.0, then we can abandon it if I don't find it fun to work on anymore. But I mean, that doesn't really answer the question. That's just... maybe in some way it does. Another tip, I guess, is also to have, like, making a game involves so many different aspects, right? You have some programming, maybe some shader work, modeling, and so on and so on. I try to vary myself, so sometimes I do a couple of weeks of like pure gameplay implementation, then maybe I do a couple of months of shader programming. When I get tired of that, I switch to modeling. So I think variation helps a lot as well. But then, of course, you also have the boring answers like just discipline. Just tell yourself that you won't abandon the next project and keep it small. I hope that answers it to some extent, at least. Oh yeah, we might want to add a couple of strings here as well. Input should be game object, and output should be creature. Oh yeah. Antonino, sometimes I think the problem is that I create it all by myself. It's as if not showing it to anyone makes me never finish it. Yeah, that might also... you might be onto something there. So, like, I think the biggest motivator for me to continue on this project and eventually finish it, hopefully, is that it's not only me that care about it anymore, but actually other players as well, right? So definitely, I would definitely recommend like getting it out there. It could be shorts or longer form YouTube videos or just streaming or something, just showing it to friends and family. 100%, that's a very good point. I like the fact that you ask the question and then you give the best answer. Yo, what's up, Riot Matt? I'm starting an application designs and development program in February, but I currently have 0 experience. Do you have any advice on what I should learn or practice in the meantime to get a head start? I have no idea, actually. Yeah, unfortunately, I can't answer that. But I can say good luck. Jank, go head first into C++. Application design and development program. Okay, development, that's some programming. Design, I don't know. I don't know. Okay, now I'm just guessing. Don't take this too figuratively, but I've heard about Figma quite a lot for the design part. And for development, I would definitely go with something easier than C++. Python is probably a good start. But I don't know. And Antonino, by the way, no need to say sorry. I think the translation works well. I have like 0 problems understanding it. Right, Matt, I will check. Thanks for the advice and good luck for your development. Thank you, appreciate it, man. Okay, let's see if we can add this node here now. Creature constant. Creature. And there we have it. That's pretty much the end node. Yeah, I'm kidding. C++ is like wielding a katana. Very easy to cut your arm off. They've added some safe guardrails lately, though, haven't they? I mean, you can do some pretty amazing stuff without even learning about pointers. Or memory management, actually. Antonina, I'm a person who asks myself questions all the time. I'm asking you this question to get another perspective, even though I'm answering myself 10,000 times. Yeah, other people's perspective is always good as well. But okay, yeah, that's one other task done. Game object to creature node. So I'm going to commit this one. And then for the last hour today, we're going to dive into creature generation graph importer. And I'm wondering, like, wouldn't it be nice for all of these nodes to have a, like, to be able to convert to its runtime equivalent? We always want to go from editor node to runtime node, never the other way around. But then we would like, yeah, we're gonna add an interface, I think. Okay, let's commit this real quick. So what I'm wondering as well is if we can do importer. Yeah, we create instance, get next node, translate node model to runtime nodes. Yeah, and then we do we do inode node model, and then we do a switch on the type then. Right. Set background. So these, yeah, this is just a list of visual novel runtime nodes. Get input value. Yeah, I think I don't want to do it like this. Instead, we're gonna do every runtime node is gonna implement a convert to, or every editor node is gonna implement a convert to runtime node, which we just call yes. Hell yeah. Okay, so I think we're gonna do it like this. We're gonna have to implement a, or we're gonna have to define a interface. So every editor, you know what? We're gonna implement a abstract class editor node, which implements node, and then all of these will implement editor node instead. So we just insert our own class in between our own classes and Unity Graph Toolkit node. Because I want to add, yeah, we want to have some functionality that are the same for all nodes. Is this weird? No, I don't think so. Let's see. Implement. Actually, so here we have generation runtime node, and then we're going to have generation editor node. So implement generation editor node. public abstract class maybe. And then we're gonna have make all editor node derive from generation editor node. Derive. What is the word I'm looking for here? Maybe inherit. And then we can remove from. And also, actually, implement or add and implement generation editor node dot convert to runtime node. Can we just do to runtime node? Wouldn't that be pretty handy? To runtime node. Mm-hmm. Yeah. Okay, didn't we get this commit? Okay, that's pretty fucked up. Whatever. Yeah, so let's add a generation editor node. Generation editor node. And it's gonna node. And yeah, so this is pretty much the first one that actually needs to use this namespace. We're going to return generation runtime node. I thought to runtime node. I don't know what the problem is, but the IDE seems to not be able to handle. It doesn't color this one or show the correct error. Like this one should be a class. This one should be the same color as this one, shouldn't it? I don't know what the problem is, but generation editor node, and we only have this function right now, generation runtime node to runtime node. So set mesh editor node, here we're going to have protected, no public, override mesh, actually set mesh runtime node. So now we need this one here. Two, maybe we can't put it like this, but that's okay. We're gonna do two. To runtime node. I want to see if we get a compiler error. Yeah, but if we, on the other, if we do generation editor node, like look at this one, the IDE doesn't work at all. Yeah, set mesh editor node does not implement blah blah blah, and if we have this one, it's going to say no suitable. Target runtime doesn't support covariant return types in overrides. Okay, beautiful. So if we just change it to generation runtime node. Beautiful. I wonder if you don't want to do it like, what the reason for not doing it like this would be. But the idea then is that we do set mesh runtime node. We want to create a constructor here now. We want to remove system serial. We want to keep system serializable. But we want to add a constructor. But then again, what? Yeah, we want to be able to set these. Maybe that's... Okay. No, I mean, maybe we don't need a constructor in this case. But the idea is that we do set mesh runtime node. We do it like this, and then we want to set the outputs. Yeah, we just want to set the, or we want to set the inputs rather. So we want to do runtime node dot input game object is equal to something, and runtime node input material. Nope, input mesh is equal to something. Yes, and how we're gonna get these, we're gonna get them in a very similar fashion to, in the sample here, what we do. Don't they do something like this? Maybe they don't actually. No, they just run through it. Yeah. Okay, so the way we are gonna do this is we're gonna utilize index name In fact, do we want to do it by name? Yeah, maybe. Actually, we want to do get input port by name, which gives us an I port, and then we call first connected port, which gives us an I first connected port. Yeah, we probably want to do this, but we want to do this if it's not another port, I guess. Although I'm still wondering. Variable node. Yeah, this is very static compared to what we are doing. So I'm wondering if Yeah, I'm wondering how I want to solve this. In this case, for dynamic mesh generator editor node, we probably just want to get these the same way. But fuck, what happens if... Yeah, what I want to add eventually is a lot of random nodes here. So it feels like maybe if we generate a triangle, we want to add a random point node, which we input here, here, and here. A random point node, maybe we set it to every time we ask it for a random point, we change the seed. Otherwise, we keep the same seed for all iterations. If it's empty like this, however, then we just want to take the values. Yeah, so I think that's what we want to do. If it's empty like this, we just want to take the value. If it's not connected. But if it is connected, then we want to reference the node instead. But how the fuck would that work in the runtime case for us? That would mean... Yeah, we're gonna have to add some constants here, I guess. So that would be... where do we have it? This is editor nodes here. Node rules, so output... Because let's say that we have this node here with 3-point inputs. Sometimes we want them to come from another node. Sometimes we just want to have it like this. If it's just like this, we want to set these vector 3s, but our runtime node is still... That's true. This is a pretty bad example. Because this one doesn't have... The runtime node doesn't have any input except for this. Fuck me. When it comes to runtime node, you know what? Yeah, I think I'm overthinking it. I think it's as easy as... we're gonna have to change... Or no, I'm not. So, dynamic mesh generator runtime. This one has a setup here, which we want to set from the graph. Yo, what's up, Ling Ling? Happy Friday, man. Okay, so the problem stems when we want to define a node that sometimes just take a constant value and that sometimes take a node entry point. I think the problem is that like we want to generate a lot of values at runtime because we want a lot of these to be randomized. Lilian, how's you doing, my man? I'm good, I'm good. Just trying to figure out, trying to figure out how Unity Graph Toolkit is working and how we can utilize it. Yeah, we have editor nodes and runtime nodes. But how about you? How are you doing? Okay, maybe it's easier to understand if we take this example, for instance. Sometimes we want to have... Nah, it's actually quite easy for this. Okay. So in this one, game object to creature, runtime. We actually just do input game object, but yeah, we expect this to be a game object here. Game object instantiator at runtime then. Yeah, here we don't take any input, it's as a setting. Ling Ling, I'm good, nice to hear. I recently played a game made in Unity, and the longer you played, the longer saving took, because the game would keep track of all loot on the ground in the entire playthrough. But it's probably no way around it, right? If you want to have persistency on that level. I guess. Aren't the developers of Star Citizen? They are trying to solve a similar problem because they want to have persistency in their whole universe. But yeah, you definitely don't want it to take too much memory. It's a hard but interesting problem to solve, I think. Kind of, but you have to deal with it somehow, lol. You don't want 1 minute save timers. That is definitely true. You can probably have some dynamic, like, you don't want to build the save file from scratch every time. That's for sure. Okay, but as for the problem I'm talking about, maybe we shouldn't have these as inputs like this unless we really have to. So yeah, we're gonna change it, but I wonder, are we able to do what was it called? Set dynamic mesh generator editor. Can we set, fuck, it's output input port. I wonder if we can do, here we want to do a switch. Want to see if this works. Oops. 76. Ling Ling, I'm no rocket scientist, but I've always wondered why people don't optimize the save files more. Smaller files, quicker saves. No? Yeah, I can't actually think of a game I've played recently where saving was that big of a problem. Prior one when doing save files, however, is you want to remove any and all possibilities of ever corrupting it, and then you probably want to build it in such a way that you can extend it without corrupting previous versions, and then maybe you can do some optimization to it. Object reference not set to an instance. What is it that we have a null context? What? Now we have context. Get node option by name. Haven't we set this one yet? Yeah, okay, that sucks. Yeah, that's probably it. So we can't do this. But you know what? Maybe. Ling Ling, I confess, my games are an HDD. Yeah, but still, okay, that's probably one of the reasons. Okay, I think we're gonna keep it like this for now, but when we convert it to runtime, we just take the value here. It's gonna be weird. Okay, let's see here. Dynamic mesh. Yeah, we will get to that one eventually. Let's jump to this one. To runtime node, input game object, input mesh. So we want to get the node, the input node, right? Yo, what's up, GDs? What up? What am I seeing? We're working with Unity Graph Toolkit currently, trying to build make it possible to define a creature visuals and probably attributes eventually using like a graph interface like this. Basically, I want to be able to define this in a graph file and then generate it based on those rules. Hey, we're gonna do this, I think. inode. What do we have? Methods. Get. Don't we have... Oh yeah, I want to check node. Define node. Can we override this one? Undefine options, undefined ports. Get node option. I don't want to do anything. On enable, undefined. Let's see here. Called during define node. I don't know exactly when this one is called. A define node. I think we're gonna work with this one actually. Oh, we can't override it. Because what I'm thinking about is, or what I'm wondering is, when we change something here, do I want to generate the runtime node at that point? I don't think I do. But then again, when we call to runtime node, we don't want to... We don't want to create more... We don't want to create two runtime nodes that represent the same object. GDs, and how is it going so far? Any blockers? It has actually been quite a smooth trip. We started with it yesterday and we already have the we have all the editor graph and the runtime graph, even though the runtime graph, we started that one on Tuesday or Monday, I don't remember. Now we're just trying to make them, now we want to convert from the editor graph to the runtime graph. This is probably where it has started to, where the resistance is starting to be noticeable, but it's still pretty nice. Virtual Ling Ling, I guess it opens up for it to be overridden pretty much. I think that's the most important part. Yeah. So it can be overridden and implemented. While if it were abstract, it has to be overridden and implemented. Okay, we probably want to do a depth first search here, or breadth first, whatever. And because we want to build up this graph on the runtime side of things as well, so we want the connections. So we can figure out the input game object and input mesh here. And that's why we can't do 2 runtime node here. But maybe we can connect these eventually. Yeah, maybe we keep this. And we do this on the outside, maybe. Yes. Yes. I think. But also, yeah, I don't know. Okay, yeah, we're gonna have to do something like this. So maybe it's not that good to have it like this. Because we can't really do this pairing in a good way. I guess that if we were able to... If we were able to... I mean, because if each of these editor nodes has a, or implements a 2 runtime node method, we can just loop through them and convert them to runtime nodes, which we put in our runtime graph. But then we need to do the connections as well in our runtime graph. So we need some way to fix the connection. But you know what? Maybe. Like what I would love to do is if we could do, yeah, let's say that we do get node via port connection, because we can do this. That means that we're going to get a generation editor node. And if we get one of those, we can do to runtime node. And then we just do it like this. So we start from the last node and we parse through the graph and do it like this. The problem is when we have, I think, yep, when we have the game object, when we have two nodes like this, that uses the same input here, because then when we try to generate or convert this into a runtime node, it's going to go backwards, find this one, convert to runtime node, or even more backwards if this one has input. And then when we want to do the same with this one, but when would that happen? This is a bad case, but as soon as we get a node that splits in two or more directions like this, and when we move backwards through the graph, we're going to come to this node from multiple different directions, which means that we're going to create this multiple times if we don't have a cache here in some way. So if we have generated this, don't do it again. Which we could probably do. Yeah, that's probably a nice way to do it. Yeah, so we start generating it. When we're done generating, we just clear the cache, pretty much. What I mean is, we have this private. So generation editor node, we changed this one to public abstract. Like that also sucks. Maybe not. Yeah, when we generate it as a runtime node like this, we're gonna have to cast it. It's not that good of a solution, but it's better than nothing. So we're gonna have to do, yeah, so we do it like this with a cache, pretty much. But then we're gonna have to do as output, or as output dot game object, because we need it to implement this one. If we want to do it like this, that is. But maybe there's a better way than defining it like this on our runtime side. I wonder if we can just keep it as game object and then check if input type is the same as output type. Yeah, probably. We could probably do something similar to... We can probably do something with T, or can we? Guess we're gonna have to cast it somewhere. Yeah, this is probably way better. Yeah, and then we're just gonna have to check if we have the same input and output. Do we want the outputs to be in a list or something like that? Or, yeah, like the runtime part of this graph, we want this one to be as quick as possible. Okay. Yeah, the time is almost up, so I think I'm gonna call it here. I'm happy with the progress. Slowly but surely, I'm trying to getting to understand it. I'm gonna look into a few examples of this, see if I can learn something, and hopefully I have a game plan or plan of attack on Monday. Like, I have a few options now that I know would work, but they would be not as straightforward as I would like them to be. And then, like, we also want to be able to extend this one. Like, we want to be able to loop, or we want to be able to group nodes, or set some nodes should be able to output multiple stuff, you know? Yeah, I have a few things I need to figure out, and hopefully I will get the time this weekend to do it. So, for instance, where do we have it? For instance, or game object instantiator runtime. This one, sometimes we might want to make this one generate X number of game objects or instantiate X number of game objects, which means that the output is going to be a list of game objects, and then the following nodes we want to do multiple times on all of, like, once for each of those objects as well. Interesting. Even though I don't find a solution this weekend, I will be back on Monday, I think. Thank you so much for watching, everybody. Appreciate it. Thank you once again, Antonino, for the donation. Appreciate it. And have a great weekend, everybody. Peace.